Welcome for our mathematics lesson. We're going to discuss loci, number 19 in this paper. We are told using a ruler and a pair of compasses only. Part 1, construct a triangle ABC such that AB equals to 6 centimeters, BC equals to 8 centimeters, and angle ABC equals to 60 degrees. So let me begin with the construction of the triangle so that we may go to the other instructions. We are first of all beginning with a length AB 6 centimeters. A length AB 6 centimeters. So mine is to do a straight line. A straight line. Then this is a point A. Then now using my ruler and a pair of compasses, I have to stand at the 0 mark. Then I pick a radius of 6 centimeters, and standing at A, I make an arc. Now this is 6 centimeters, and this has to become my B. The next thing is the angle ABC, which means the angle at B now is equivalent to 60 degrees. So I'm supposed to construct 60 degrees at point B. So standing here, using a certain radius, I have to make an arc. Then standing at this point on the line, I cut the arc on the upper part. The line I will produce here now will be 60 degrees. This is an angle of 60 degrees at B. So C is somewhere such that the length BC equals to 8 centimeters. Therefore, I can elongate this one before I measure. Yes. Now I can stand again at the 0 centimeter mark. Then using a radius of 8 centimeters. Using a radius of 8 centimeters, I produce an arc on this line. That will give us my point C. My point C. And I can now join it with A. I can now join it with A. Yes. So that is how it is. The next question now is part 2, which says, on the same side of BC as A, so using BC, the side where A is, construct the locus of M such that the angle BMC equals to 60 degrees. So I want us to construct a locus such that B, then to a point M, C, will get 60 degrees. This is called the constant angle loci, and it's constructed such that it's a circle loci, whereby using B and C, there is a circle somewhere where we can only produce angles of 60 degrees. Therefore, if we need to be having our BC, let me illustrate it like this. We have our BC like this. Then there is a point whereby we should produce angles of 60 degrees. Then it means there must be a center whereby we are having angles of 120. An angle of 120, so that anywhere on this circle, we will have 60 according to the angle properties of a circle. On the circle, anywhere we will have 60 degrees, as long as at the center here, we have 120 according to the angle properties of a circle. That means we should identify the center now, such that using B, we can have an angle of 120 at that center. And that means we need to have angles of 30 at the base here. Angles of 30. So we need angles of 30 on this side, and also an angle of 30 at this point, so that we may get a center which is having 120 degrees. So let me hold my paper well. Therefore, I need to use now my protractor, my compass, sorry. I need to first of all bisect this first 60. Therefore, when I bisect this 60, whatever I'm getting here is 30. Then I go again to the other side at point C. I make a 60 and I bisect it so that I get 30. Okay, this is 60. So we can bisect this 60 now so that we get 30. Can bisect this 60 now so that we get 30. So bisecting 60 means I stand here, I make an arc, then at this point, the same radius, I make an arc. So now, when I connect C with the intersection of the two arcs, it means I'll be bisecting 60 degrees, and that means I'm now having 30 degrees. I'm having 30 degrees. That automatically means that I'm having 120 degrees. And now with the 120 degrees, I can now construct my constant angle loci, such that I will need to use this one as a center now. Then I come to B. Yeah. Also connect it with C. And I can see the concept is agreeing. So I just need to make that circle now, the constant angle loci. Therefore, I will stand at C and make an arc. Yes. So now this is what we call the constant angle loci, such that anywhere on this circle now, we call it M, such that anywhere on it, we can produce an angle of 60, now that at the center we are having 120. So that is the locus of M, the constant angle loci. We can check something else. Part 3. Draw the locus of a point Q, which is equidistant from B and C. The locus of points which are equidistant from two fixed points, B and C, is the perpendicular bisector of the line joining the 2 points. You better master that one. The locus of points equidistant from two fixed points is the perpendicular bisector of the line joining the 2 points. So we need a perpendicular bisector of BC. That drawn, it will give us the locus of points which are equidistant from both B and C. Therefore, I want to bisect BC now. So I need to stand here. I produce the radius. I make an arc. And I make an arc on this other side. Then now I come to this other end. I make an arc. And I also make an arc to cut the first one. Therefore, now I can produce my bisector now. I can produce my bisector. So this is the bisector of BC, and it is the locus named Q. This is the locus Q. We can continue to part 4 of the question. Remember, this one is done now. Draw the locus of a point R such that RC equals to 3 centimeters. This is RC equals to 3 centimeters. the locus of R such that RC equals to 3 centimeters. This means R is somewhere such that from C we have 3 centimeters. And when you are given the locus of a given distance from a fixed point, it means that is a circle whose radius is the given units. Therefore, we need a circle radius 3 centimeters, and we use C as the center. We use C as the center. So I want to measure my 3 centimeters. 3 centimeters. Then now using these 3 centimeters, I will stand at C and make a circle. Stand at C and make a circle. Now, this circle, anywhere on this circle, we can call it the point R. Anywhere on the circle, because you find that RC is 3 centimeters. Because I've made a radius of 3 centimeters, then the circle. The next is going to be draw the locus of a point P. The locus of a point P such that the area of the triangle BPC equals to 12 centimeters. BPC equals to 12 centimeters. Remember, BC is already given. BC is already given as 8 centimeters. This means now with BC, this is BC, 8 centimeters. For us to get area of 12 square centimeters, we need a height which is not known. We need a height which is not known. And this means the height can be calculated. So you say area of 12 equals to half a base of 8 and a known height. So that this becomes 4 and our h becomes 3. Therefore, we're going to draw such that the point P is at a point whereby from BC it is 3 centimeters away. And such a locus whereby we need to construct the locus of points which are at a given distance from a given straight line. We usually do a parallel line to the given line such that the parallel line is the desired distance away. And this is how we're going to do it. From BC we shall construct a parallel line which is 3 centimeters away. 3 centimeters away. So I'm just elongating the line BC. I'm prolonging it so that standing at B, I can produce a bisector. Standing at B, I can produce a bisector. I make an arc. Then I stand here. I can make an arc on this side and stand here to cut the same arc. That means when I produce a line through B, it will be perpendicular. And actually my line can be dotted because it's not the desired vector. This is a line which is just perpendicular at that point. We can do the same at C. Such that, because this one has been prolonged, I'll need to stand here. I make an arc. Then on the other side, I also make an arc. And I enlarge a little bit. Standing here, I make an arc. Standing here, I make another arc. Therefore, I can do a parallel line through C. I'll also make sure that the line is dotted now that it is not the desired locus. Yes. Now with those perpendiculars, dropped through B and C, I can now measure the length 3 centimeters. The length of 3 centimeters. Yes. Then I stand here. I make an arc. Stand here, I make an arc. And on the other side. Then, when I come to B, I do the same. Standing at B, I will need to make an arc. Then I make an arc on the other side. So this means when I join those arcs, I'll be having very parallel lines to BC. So this arc and the other one. This is a line which is parallel to BC, and it is 3 centimeters away because this is 3 centimeters. Remember, the arc here is 3 centimeters, and also the arc here is also 3 centimeters. I can also make it on the other side because I had not been limited to the side I will do it. So I can also have the same on this side. Therefore, any of those two parallel lines to BC is the locus of points P. The locus of points P. This is P. This can also be P. Using BC, we can produce a triangle to the locus P, and that triangle will have area which is equal to 12 centimeters squared. Now that the line P is 3 centimeters away, to mean the height will be 3, and this is already 8 centimeters as the base, and the area will automatically be 12 square centimeters. Finally, we've been told to locate the region by shading such that the angle BMC, remember we have the locus of BMC, the locus of M is this constant angle loci. BMC is greater than 60. For the angle to be greater than 60, it has to be, the desired region should be the inner side, because if we produce an angle beyond this, it will be smaller than 60. So for the angle to be greater than 60, it has to be either on M or on the inner side. That is something you're supposed to know. Or on the inner side. So I've shaded the unwanted side of that locus. The next thing is to ensure that BQ is greater than QC. This is the vector, the locus Q. So we want BQ to be greater than QC. So for it to be greater than QC, then BQ should be beyond on this side. Therefore, it means we shade this side. We shade this side. We shade this side. So this side now, BQ will be greater than QC on the required side here. The other one is RC to be greater than 3. This is RC equal to 3. So for it to be greater than C, then we are supposed to have it shaded inside. The circle should be shaded inside, so that greater than C is on the outer side. So the required is the outer side. Greater than 3 is the outer side of this circle. Then finally, the area of BPC greater than 12. BPC greater than 12. To be greater than 12, it means the height should be beyond these 3 centimeters. Therefore, we shade the lower side, which is lesser than 3. Shade the lower side, which is lesser than 3. Therefore, you discover that there is a region satisfied by all those conditions. And this is the region. I can call it R. So that is how we come up with the desired region. Thank you for following. Subscribe and share.